If you're the kind of senior engineer, architect, or technical leader who people look to for what's next, QCon London is probably on your radar. Join us in London from March 16th to the 19th, where we go deep on the topics that matter, like the architectures you've always wondered about, engineering productivity, and applying AI in the real world. This isn't about trends for their own sake. It's about getting practical insights from senior practitioners to help you make smarter calls on where to invest your time in tech. With software changing fast, QCon London is a conference that helps you lead the change. Learn more at qconlondon.com.
Hello everybody, I'm Olivier Pop, an InfoQ editor, and I have in front of me Vivek, and he has a very interesting scenario from Stripe. Vivek, can you give us a short introduction?
Yes. Hello everyone, this is Vivek Yadav. I am an engineering manager at Stripe. I have been working at Stripe for the past 8 years, playing different roles as an engineer as well as engineering manager. And most of my time I have worked in one area of Stripe, which is how Stripe build our users.
Thank you. Stripe is quite an impressive company that has an interesting share of the global payment system. So I'm very curious to see what you actually put together. But before that, can you give us a short introduction of how you got into software engineering, software computer science? Because each of us has an interesting story. So what's yours?
Absolutely. Yeah, my story is kind of odd, but yeah, I did not touch computers till I enrolled into a computer science course with the university. I grew up in a village, did not have access to any computers or anything like that. I did well in school, and when it was time to get into the university, I just asked around, hey, what should I get into? And thankfully, people suggested computer science, and since then, I've been enjoying this field.
Okay. And the reason why we're discussing now is that you used Apache Spark in an unconventional way, not the way how people usually use Apache Spark. So what was the problem you're trying to solve?
Yes, absolutely. This is a common scenario that pretty much every large-scale systems run into again and again, which is migrations. We write a system. After a few years, the system does not scale. Like the inputs and outputs are generally the same, but the internals of the system just need a rewrite because just business logic keeps getting complicated and complicated. And then we have to redo the abstractions, right? And when doing so, usually speaking, we want to make sure that we do the migration in a way that the previous input and outputs are basically unaffected. The way the system, whatever system was able to handle before, it can handle the same things exactly the same way without any impact to the users, except that it can handle more things. In our use case, we were doing a migration and we had to make sure that the migration will be safe enough. And we wanted to make sure of this by testing our new code with past multiple years of data. Again, we are dealing with money, so we have to be very careful and make sure that everything is correct. And now we could sort of, let's say, have production scale system and imagine now you're doing a real-time service and your real-time service is designed to handle certain kind of load. If you want to run past 3 years, 5 years worth of data through that service, it will take a lot of time to test that service. But we came up with an interesting strategy, which was essentially, hey, could we leverage Apache Spark for this testing? And how do you even do that, right? Now, if you look at every service in a simplified format, every service is really doing a bit of I/O and doing a bit of business logic. You get in a request, you apply some business logic, you send a response back. You may be doing some DB writes in between. And sometimes you have a chain of these events as well, which is there's the input, there's a business processing, there's the output. That output is taken by some other step in the business processing and so on, right? So you can squint at your services in a way that you can basically see them as a series of business logic operations with some inputs and outputs. In a very simplified format, this is very similar to Spark. In a service, your input-output is happening based on basically a request coming in, whether it is gRPC request or some API request, and the response going out. In case of Spark, your input and output is happening on top of a Hive table or HDFS files or S3. So you read in bulk rather than getting one request at a time. You read in bulk and you write in bulk, and you basically do their business logic in between.
Let me stop you here. So to just make sure that I understand correctly, oversimplifying everything, what you actually did is a regression testing. But the regression testing that makes sure that the transactions, probably billions of transactions that Stripe has each year, are used as data to just make sure that everything is fine, right? And then oversimplifying everything, you have more or less a framework of allowing you to test those things where you have input and output. And basically just to make sure that the processing is pretty much the same thing, right?
Yes, absolutely. So doing this requires a bit of discipline in terms of how do you write your service. So if you could write your service as effectively, think of it as the core logic is a library. That library essentially takes in some configuration at the startup time essentially, and then it can basically serve request. Like it exposes some methods out, and you can basically, you get an API, you call the method, you get a response. Now the same library can be wrapped in a Spark wrapper as well. So let's say if we have a service, we could deploy the service in multiple environments. We could have a production environment, we can change the input output there. We have a queue environment, we change the input output, DB, everything there, right? You have local test environments as well, where you basically override some configs and change the input output. Similarly, Spark is just one more environment where the same code can execute, except your input outputs are happening on top of Hive tables or S3 files. And your configuration basically is just one-time setup again. So the key point is, organize your code as a library and then add the layer of I/O around that. Now, one type of I/O makes that a service, another type of I/O makes that a Spark job, essentially. Once you have this setup ready, then you can set up like years worth of data in a matter of hours, essentially. Because Spark, you can just run this massively parallelly with Spark. But if you're doing with a DB or anything like that, then it's just too slow and you cannot just scale it that fast.
Okay, so more or less what I'm hearing you say is that you have data split around, let's say, buckets as different containers of different types of data, and then using the abilities that Spark has, you can just parallelize everything and do it in a decent manner in terms of time. And then rather than having something that goes over a longer period of time, you're just doing it in half a day or a day maybe.
Yeah, exactly. So the key thing Spark has with it is basically, is rather than reading sort of, let's say, taking one request at a time and writing one response, it really reads bulk from S3 and writes back in bulk to S3. And so the other critical component here is like, again, this kind of testing scenario does not fit every application, but it really fits if your data is already copied over to S3. So in a lot of production scenarios, right, you generally will have a real-time service ongoing, but you also will keep a copy of your data in sort of, let's say, cold storage for various analytical purposes. In case of Stripe, not everything is available in S3, but a lot of scenarios we need to do a lot of other analysis. And so a lot of data is available in S3. So in our case, we already had copy of our requests and responses in S3. So it was having Spark on top of that was like very natural choice. We already had other Spark jobs doing work on top of that data for different purposes.
Okay, so that was my next question, but you already figured it out. Is that oversimplified? It's an assert statement. You have the request and the response. So basically what you're doing is you're using the same request pushed over, and then you're just comparing it. And what would be the output of this system? Because I imagine that years of data means probably in the order of billions of transactions or whatever. What's the output? I mean, normally you'll just get, when you're running a set of tests, you'll get, okay, these kind of scenarios are not the ones that you expected. But if you're running on billions, you'll have a very long scroll and to just check everything. So what's the output?
Absolutely. So there are many use cases here, but our first use case was just a migration and a back testing of that migration. In the cases of back testing, the expectation is that, so we already had a previous production request responses, right? And we now played the previous request against the new code, and we got new responses. So now we just need to compare the new response data set with the old response data set and make sure that they're exactly the same. So you can basically, on top of that, you can just write a custom diff job or a generic diff job as well, which basically compares the two and then gives you the, hey, where are they differing? What are the rows that are differing? And then you can analyze those rows, fix your code, rinse and repeat.
And looking at the life cycle, the classical life cycle in terms of deployment, is where is this happening? Is it, as you mentioned earlier, it's in the staging environment, or you're on top of that because you're in a very regulated space, and I would expect that you cannot just go and do continuous deployment and do releases and so on and so forth. So I'd expect this to be a very sandboxed space.
Absolutely. Yes. In the Stripe environment or any other regulated environment, all of the code that is running in a very controlled environment, essentially. So this is not like, none of this code is running on my local machine or anything like that. Stripe provides, and other companies of that shape also provide sort of, let's say, environment to the developers where the environment complies with all the regulations by default, and you can run the code in that environment. By the way, I want to call out, this is not impacting production at all. This is like within, like even though you are sort of, let's say, using some sort of production data, and when I say production data here, I want to clarify, none of this is customer identifiable data as well. So all that work is already done before the data goes into cold storage and so on. Like Stripe has excellent security and so on. Every bit of compliance is done on top of that before it reaches in a way that any human can really look at it. So there's no identifiable information here. It was not even transaction data. It was the network cost data, which is like one level deeper to transactions.
Okay, so to just make sure that we have this clear, there is no PII involved because the data is anonymized, so there is no case. And on top of that, given the critical nature of the system that you're putting together, everything is done in a separate environment to make sure that the production is not affected. So everything is air-gapped, so everything is in a safe place.
Yes.
Okay, looking at it, just trying to visualize the architecture of everything, you have buckets, S3 if I understand correctly, so AWS is used on that side. Then you have data in and out at the network level. And then you have Apache Spark to be used as the glue between those 2 points. And then you analyze if there is something that's not working as expected in terms of regression testing. You're just looking at that, and then you zoom in.
Yep.
Are there everyday engineers that are doing that? Or you have, a specialized work group that is like QAs or engineers in testing? Who are the consumers of this framework?
The consumers of this framework are basically engineers who own different services, essentially. So the engineers are responsible for testing their code. This is not going to, like, especially in this scenario, it's not like we are relying on a QA or a test engineer. Engineers are end-to-end responsible for their thing. So like if they're making, let's say, if I'm responsible as an engineer for doing a migration, then I'm basically using this framework to make sure that my migration is going to be correct and sort of debug my code as well, whatever I'm writing. There are many more scenarios that are enabled along with this. Basically, we made this Spark-based testing as a solution for migration, but later we realized that, hey, this can be used in a bunch of other scenarios as well. So another common scenario I'll give you is, again, this is not widely deployed, not every service is applicable here, but in our case, whenever I'm making a code change to my service, now this is not a migration, this is a small code change, right? We have a golden data set ready, which is, let's say, a few million requests, a few million responses. And when I commit that code, I can basically tag, hey, can you just make sure that this code is safe? And that from the GitHub, this will trigger a Spark job, essentially, that just reads the request, has the expected responses, and then the new responses, and just make sure everything is right, attaches back the responses, the diffs back to the PR to just make sure that even small code changes are correct. And this happens in order of minutes.
Okay. That changes the landscape, because normally, if you're talking about the last validation step, that's okay. You can run it overnight. You can run it in a different type. But if you're discussing about just as a feedback loop for developers, then you have other perspective that you have to take into account. And that was my question of how much does it take? Because usually, you have engineers that are complaining about it takes too long and then they are just losing focus. But a couple of minutes is quite okay. Then if you're discussing about the golden set data set, I would suppose that it's pretty much always the same data set, or is something that is just sequencing?
We started with a same data set, and obviously with time, your shape of data changes and so on. And we realized, hey, we've got to refresh that golden data set time to time. And so now we have a script that basically run the script. It will basically regenerate the golden data set based on the latest data and so on.
Okay, great. Thank you for sharing that. And now, as we touched on developers and something that is closer to the inner feedback loop, how do you see the developers? And now I'm touching on your engineering manager skills, because up to now we discussed about the engineering side. What's your metric? How did the code base improve? Do you see less defects at that point of time? Do you see happier developers? Because basically I would say that these are the 2 points that should count in this landscape.
Yeah. So I think there are two key things here. One thing from the developer's perspective is just having the confidence for the reviewer that they are reviewing the code quality and they need to worry about bugs less compared to before. So like if you're reviewing the code and you already have a bunch of tests passed and sort of that code has also been run against millions of transactions and hey, this works out fine, that gives you some confidence that the code is correct and then you can just go for the quality-based review. So that's one part. This is just more confidence in the system. The second thing, and like that's why we actually attach to the code reviews, is we want to catch the regressions basically before they reach production. And there's only so much you can do with the unit tests and the integration tests. And so we just wanted to have one more layer of safety to catch things before they go to sort of, let's say, production system and they're live, and then we detect it live. It still happens, but this was like a massive like a step change in terms of like how many issues were happening because of a code change.
So to see how the landscape looks like from that point of view, because you have different ways of looking at testing, and those were the pyramid of testing, and then there were a couple of guys that were saying about the reverse pyramid of testing, and then there were some people who were like diamond of testing, and all other sorts of geometrical shapes and figures and, gems and other stuff. But you touched on two other ones. One of them is unit testing, and then, as the name suggests, that's for very small pieces of code. And that will allow you to show how the code is running in isolation for you as a developer. But then you have a lot of other stuff like integration testing and then regression testing and so on and so forth. So how does the landscape looks like? You have unit tests, and what are you targeting? It's like 20%, 15% in terms of unit testing and then everything else, or it's more hunch-based and you're just focusing on that?
I would say this really changes from use case to use case, part one. And it also changes from like what's the maturity level of the system you're working at, right? I'll give you another example. I'm working on a greenfield project right now. The project is like not yet in users' hands. We are iterating fast on that and so on. Like, so right now we are not really caring about like what's our unit test coverage. Our key thing is like, hey, let's get a solid enough base ready that actually serves some core purpose. And just before we go to the users, that's when we start having unit testing. Now, also it depends on like, is the system going to move money or is the system just a internal tool or something else? If something is going to move money, there's no amount of testing that is enough. You basically go for all in. You try to basically have the highest number and so on, right? But if it is sort of, let's say, a less serious system, then you got to be careful about how much resource you devote to testing. So like, I don't have one ready-made answer. It really changes from what's a scenario in front of you.
Okay, so you're adapting based on what you have and the outcomes and so on and so forth.
Absolutely. Anything that is touching users and money movement and so on, that definitely gets the highest level of testing.
Okay. Normally, with these tests are at some point appearing on a dashboard for some kind of management. So how did the numbers improve? You said that it's a massive scale, but what should you expect? Or you said also that it's not something that you use in every kind of system. What kind of systems you should use it for?
Yeah, I think this is Spark-based sort of, let's say, testing of JVM services. So this will fit in a scenario where your code is already written in a way that it can run in a JVM system. So if it is a Scala code or a Java code, that will work in JVM system. That's one part. The second part is this will work well, or let's say cheaply, in terms of development cost if you already have your data copied over to S3 as a part of normal sort of, let's say, ETL process. A lot of, let's say, Stripe-shaped companies have those ETL processes, and a lot of data is available in S3 systems. And so you already have the data you can write on top of that. And finally, I'll say that like, if your job is not doing too many state lookups, so your service, what I mean by that, like some services are very complicated in terms of like, hey, give me this customer information, give me that user information, and there's some conditions and do something. This will not work there. But some services are very sort of, let's say, contained within themselves. In our case, the two services I can give example of like, this is a transaction that is happening. What will be the network cost of this transaction? So network cost is essentially the cost Visa or MasterCard or any other network will charge for this transaction. We don't need to call anyone. All of that is based on a set of configurations. The configurations are pretty heavy. There are a few thousand set of rules that will determine these costs, but they are very contained. You don't need to call. You can just load them once and it will work out, and you have a bunch of logic written around them. Similarly, this is a transaction. What will Stripe bill a user for this transaction? That's a very similar kind of calculation as well. And that also doesn't require too many lookups around, right? So if your service is more contained and it is not dependent on other services too much, that's where this really, really fits.
Okay, let me squeeze a bit of conclusion. So just making a parallel to programming languages, normally we said that imperative programming languages, you had a lot of state, more or less, right? You had a lot of things to contain. Then nowadays with the functional, you're just discussing about in and out. And basically you had, depending on the different type of data sets, you had the similar things. You applied the function to an input and you had an output. And more or less, that's how the Spark-based system is working, but that's not always the case. And now you thrown in the ring other 2 points. It's about optimizing for your network cost, where the network cost will be the providers and the things that are out of your reach. In this case, be it MasterCard or Visa or any other providers or the guys that are creating the interaction between the banks and the user itself, right? And then that's a huge amount of configurations that allow you to do it, and that differs from one side to another. And that's the points that you would like to change, to adapt to. So then it's a whole different perspective, because probably you have to match inputs and outputs, but also configuration. So that's something that is a little bit more exponential rather than linear in this case.
The configurations in our case is like, yes, what Visa or MasterCard will charge for a thing, we are not making live calls on them. They basically publish their rules, like this is how we are going to bill you, and you can encode those rules into your system. So those configurations, we have operations teams to actually translate the configurations coming from Visa and MasterCard into sort of, let's say, internal rules that our systems can execute. So there are a few thousand lines of rules essentially rather than anything else. And so they're very contained. They can fit in memory of one system as such once they have translated. So like that does not really increase the complexity of the system. But that actually brings me to another interesting use case of the same thing, which is time to time, these configurations change. So ultimately, we are trying to figure out like one use case of this Spark-based testing is like regression testing, right? But another use case of the same thing is what if testing. What if testing basically means that you were playing in this world with these rules. What if rule changed from these set of rules to that set of rules? And then what will be the change on the output? As an example, let's say your telephone company charges you $20 a month, and that has some impact on your yearly budget. What if your telephone company started charging you $40 a month? What would be the impact on your budget? That is a what if testing. A configuration changed, what will be the impact on the output?
So one facet of what you're saying, on the added value that you're bringing with the system, one of them is regression testing that is on spot with data that you had and without any kind of headaches. The other thing that you're currently mentioning is more or less outliers, things that you're just thinking, or maybe a better term would be chaos engineering, where you're just throwing different things and how the things look like in that kind. And then that gets more into the space where Spark is actually used in terms of analytics. So you're just making projections. So that's not only used for engineering, but also the business side can ask what if questions and provide better answers. Okay, that's quite interesting.
Yes. Just to make that more concrete. So one example of this is like, we have a scenario which is, well, rules of this networks are going to change starting October. And the current rules are this and the new rules are that. And then we need to give projection to our finance team or our sort of users as well, like how is your underlying cost going to change? Well, we could run the new rules and the old rules on same data and figure out what's the difference. And then based on that, we can give pretty accurate estimation on how the future is going to behave. And that's like one of like a loved features our users have.
Okay, talking also in terms of looking at companies from the business impact, it is quite useful because it will provide you more in-depth views on different types of things. You mentioned S3, that this kind of implementation is very reliant on having data in S3. What if we have, you mentioned the what if testing, so let's do a what if testing in this space. What if we have a different type of data container, database, whatever? You mentioned Hive as well. How should I approach it as a developer? I want to use something else.
Yeah, I would say as long as Spark can read from that data set in an efficient manner, it works. When I say efficient manner, basically, Spark is good at reading in parallel from disk, basically, right? So if you ask Spark to read from a, let's say, JDBC connection or something from a DB, it will read, but it won't be efficient, right? So as long as you are able to leverage Spark's efficiencies, it will work out. Underlying dataset could be any HDFS solution.
Okay, so what I hear you saying is, as long as you have an efficient way of reading, probably some kind of adapter or whatever, what Spark has, it will be efficient. In case of, just to remain with your example, JDBC, probably it will be limited about the number of connections that it can have and all these other things that are related to the databases. So that it will be a bottleneck. If in your case, it will be a limited number of data sets that would make sense, it might work, but then it defeats the purpose because you will normally go, it will be too big of a hammer for that kind of problem. Thank you. What else should we know about your system that I didn't ask?
I think the other interesting situation here is that this is very cheap to run compared to any equivalent testing of this shape, which is like, let's say if your problem statement is you need to backtest 3 years worth of data in 1 day, it will be very costly to do that in anything else other than Spark or similar system.
Okay, but to just get more concrete, first of all, what would be the alternative? Because I would suppose that when you took this decision, you didn't say only, okay, we already have it, let's do it. What are the alternatives?
Absolutely. So the other alternative we initially considered was essentially having a database like a Postgres or Mongo type of database where you basically dump all the data. You massively scale that database for whatever number of days you need to do the testing. So you spin up the database, you load the data, scale the database up to load all the data to begin with, and then run the test on top of that. You could basically write a thing on your service that runs this test. But that just requires huge amount of setup and tear down because you don't want to maintain that database for long term because just for testing purposes. It's just implementation cost was too high as well as infrastructure cost was too high. While in the case of Spark, we had basically near zero implementation cost because we already had the Spark infra and so on. And this was nothing for Spark to deal with. It's like a very trivial amount of load as such for Spark.
Okay. So what you mentioned is that currently there is a hype or whatever. The trend in the industry is to use ephemeral testing. So to just drop a bunch of the testing environments, so to just have the development environment. And then after you're done with the inner loop, for the outer loop, you're just using ephemeral environments and that's it. What you're saying is that you already had this thing, so it was pointless to implement something new. And the Spark is so heavyweight due to its analytics target that it was quite easy to adapt to that. Okay, and then you're saying data in terms of, okay, for this amount of data. Just give us a ballpark estimate. What are we talking about in terms of, and what kind of unit? Are we talking, I don't know, billions of rows, or what will be the unit that we should think about?
The scale of our system was basically somewhere around 400 plus billion rows and growing. In terms of data size, it depends on the projection, but it could range from anywhere between 2 TB to 5 TB.
Okay, so that's a lot of data, right? So probably this would be something that you'll just want to do. I don't know, I'm just thinking now also in terms of weather projections and all these kind of things where you have a lot of data, and that would be in terms of scale, because I think not that many people are just looking at those kind of things and they need to be that accurate in terms of predictions. Okay, that's interesting. You as a company are very much in terms of learning. I know one of the things that struck me in terms of Stripe is the writing culture, where you're just looking into having a lot of stuff being written and then iteratively improving and looking at business impact. How can the current system be improved? Don't tell me it's a perfect system, because I will not believe you.
Absolutely not. No, our systems are, let's say, there's a lot of scope of improvement all around. In our current system, honestly, all the improvements are on the business side of the solution. So when I say business side of the solution, it's like the core system I was talking about is like, how do we bill our users, or sort of, let's say, how do we estimate our underlying cost, like network cost? There are a lot of different shape of costs that always keep coming up. and like system keeps getting stretched. Currently, the system is designed from the perspective like you have this one input coming in a very functional way, essentially. Like you have one input coming in, you apply some logic, you have output going out, right? So two different requests are treated very independent of each other, like they're not related to each other, but like sometimes there are new use cases that are coming up where like, well, cost of this new request coming in actually depends on some previous request that you have seen, and you actually need to care about state. And we don't do that very well today. The state management basically happens slightly outside the system in a way. And if we could somehow bring that into the fold, that would be easier on our users.
Okay, so meaning the users, the business part of the organization that actually looks in terms of projections and how to use it.
Yes.
Okay, great. Thank you. Well, normally I would discuss with engineers to become more product. Now you're just talking on the product, well, business to just be more engineerish. Thank you, Vivek, for all your time. Good luck with your work and thank you for sharing your thoughts.
Thank you, Olympia.